All right, welcome to this session on applications and problem solving. This is a tool that's used in all of math classes, and we'll show you today just a nice little method to go through. It won't make every problem solving question easy because they all you have to struggle through them and try and find the concepts and the mathematical principles that you can use. But hopefully it'll help you with an attack strategy that you can use with any problem. So our outcomes today is we hope to be able to solve applied problems by translating into equations and solve a few basic motion problems. We're going to look at two problems today, one about a cycling race and one about a paddling. But let's look at the steps for solving these things first. So here's the 5 steps that many textbooks suggest that you use. First is to familiarize yourself with the question. Draw a picture, draw lines, doodle a little bit, but try and figure out what the question is asking you, sort of in picture mode. Try and get a handle, a grasp of what they're talking about. And then take that and try and translate the problem into some kind of an equation. So something is equal to something. Then we can solve it. So then that's the third step, is to actually solve the equation. Check to make sure your answer makes sense. And then finally state your answer clearly. So let's do those 5 steps with 2 different questions. The first one is a Tour de France question. It says cycling is a race that covers 3,500 kilometers in France, Belgium, and other neighboring countries. If a cyclist has 4 times as many kilometers to go as he's already completed, how far has he come so far, and how much does he have left? Okay, so it's cycling. Okay, so I'm not sure about, well, maybe I'll just draw a bike for now. There's a pretty bike guy on top of it. Let's see. So 3,500 kilometers. Maybe I can draw a line to represent the start and finish, and that whole way is 3,500 kilometers. Okay? And it says he has 4 times as many kilometers to go as he's already completed. So he must be right near the start here somewhere. Like he has 4 times as many to go as he started. So I don't know, I'll throw a line maybe there. So there's 4 times as many as he has started. Maybe let's fix this distance. So from the start to where he is right now, let's call that x. See, I'm starting to throw some letters in. And then this distance from here to the end has to be 4 times whatever that is. So this distance from there to there must be 4 times x. Okay, so I'm saying from start to where he's at now is x, and he has 4 times that left to go, and the total distance is 3,500. Okay, I think I've got a pretty good handle on what I need to do. Let's go on to the next question where I put this into some kind of an equation. So I'm translating into an equation. So from the start to where he is now, that was x. And if I add to that what he has left, what was that again? Oh, 4 times x. 4x. So if I add what he's done already, plus what he has to go yet, I know the total distance was 3,500. Now I've got an equation that is in one variable, and I can solve it. Let's go to the next page and solve it. So x plus 4x is equal to 3,500. Add these together, that gives me 5x to collect like terms. Use the division property, divide both sides by 5, and I get 700. What does that mean? Oh, let me go back. So that's x, and x was this distance right here, 700. So that means the distance he has left to go is 4 times 700. I think that'd be about 2,800. Do those two add up? Yeah, they do. Okay, so let me go back to here. So I solved for x. I got x to be 700. I'm checking my answer. I sort of did that back here, but I'll do it again. So 700 was how far he had traveled so far. And then I had to add to that 4x, which we figured out to be 2,800. And our check is to see if that indeed comes out to 3,500. 700 plus 2,800 does indeed give us 3,500. So my answer checks. So in my stating my answer then, I'll say the cyclist has gone 700 kilometers. Now, did they ask another question? How far has he come so far? Okay, he's gone 700 kilometers so far. How much does he have left? Oh, that was the other part. He has 2,800 kilometers to go. Wouldn't that be fun to go in a race where you have to bike 3,500 kilometers? Wow. Okay, so there we've taken one question. Initially, maybe it didn't seem too bad, but I was able to familiarize myself with the question, draw a little doodling kind of thing. Then I was able to translate it into some kind of an equation. I solved that equation. Then I checked to see if my solution made sense and whether it checked out. Sure enough, it did. And finally, I stated my answer. So that's the process we want to go through for applications. Here's another one. Another question. I'm paddling a raft in still water, and I can paddle 2 kilometers an hour. That's pretty fast paddling when you think about it. 2 kilometers in an hour. Well, maybe not. Maybe you should be able to go further than that. But anyway, they're going 2 kilometers an hour paddling. If the speed of a river is 6 kilometers an hour, how long will it take to go 4 kilometers down the river? Okay, well, let's, here's a boat. Sorry, it is a boat. And my paddler. And I can paddle 2 kilometers an hour. So if I'm going this way, I can paddle at 2 kilometers per hour. Okay, but then it says he's in a river, and the speed of the river is 6 kilometers per hour. So the river down here is going 6 kilometers per hour. I'm glad I'm not paddling upstream. I'm glad I'm paddling downstream. Okay, and then it says how long, so I want to know the time, will it take me to go a distance of 4 kilometers? Okay, I think I'm pretty good here. I know this formula here. My velocity is equal to distance over time. Looks like I can figure out a velocity. Distance, I know is 4. And my time, oh, that's what I'm trying to figure out. And that's nice to have a formula where you can find all three things, or two of the things, and find the third one. Okay, now one thing that bothers me is here about these speeds. So if I was a person standing on the side here watching this guy going down the stream, how fast would he appear to be going? Yeah, you're probably thinking what you need to do is add the speed of the river plus add the speed of the paddling. So yeah, I think that the total speed here, his velocity total, would be the sum of those two, or 8 kilometers per hour. Yeah, okay. Okay, so I have a velocity, I have a distance, I need a time. So let's go to the next one and write down some kind of a formula. So my formula was velocity is equal to distance over time. I need to solve for time, so let's just manipulate the formula quickly. Hopefully you can do that. Time is equal to distance divided by velocity. You can manipulate this any way you want, but this is what it should come out to. Now, time is what we're looking for. Distance, I know, is, let's do that. I'll just do it over on this side here. So time is equal to, the distance was 4 kilometers, and the velocity was 8 kilometers an hour. 8 kilometers per hour. Instead of going per hour like this, I'm going to flip that. Because this is a double divide, instead of going per hour, I can just slip the hours up to the top. Sort of a nice little physics trick. Okay, so there is my formula. Now I can go and solve it. I probably could do it here, but I have a new page for that. So I have time is equal to 4 kilometers divided by, the velocity was 8 kilometers per hour. Kilometers cancel, 4 divided by 8, 0.5 hours. And that was the units that were left. Okay, so I'm thinking half an hour. Let's check to see if that makes sense. So let me go back to this slide right here. So if I'm going 8 kilometers an hour and I have to go a total of 4 kilometers, it does make sense if I'm going 8 kilometers in 1 hour that I could do half that distance in half an hour. So yeah, I'm feeling confident that my 8 kilometers in 1 hour, therefore 4 kilometers in a half an hour, I'm feeling confident that that makes sense. So finally with this one I would state my answer, and I would say it would take the paddler half an hour, 30 minutes to complete 4 kilometers. 4 kilometers. Now, one thing with me, I would probably say, hey, I'll just coast and I'll just drift, and it probably won't take me very long to get. I might be a few minutes late, but it won't take me very much longer. Just sort of guide it through all the rapids. Okay, so those are 2 examples then of using application or problem solving to solve some kind of an application question. Remember, you familiarize yourself with the question, translate it into some kind of solvable equation, and then actually solve the question. Check to make sure that your answer is right or makes sense, and finally state your answer. Hopefully that will help you with any problem solving that comes your way.